Hello students, how are you all? I hope you are doing absolutely well. So in our previous lecture, we have discussed regarding the introduction of acids and classification of acids based on their source. So on the basis of the source, we have basically two classifications, that is organic acids and inorganic acids. We have seen that organic acids are derived from some source, that is from some organisms, and inorganic acids are actually derived from the minerals or rocks. So these are also known as mineral acids. So one thing that is also about the organic and inorganic acid is that organic acid mainly consists of carbon as their basic constituent. So if I'm talking about our first category, that is organic and inorganic acids, so we can say that organic acid mainly consists of carbon as their constituent. It means carbon is essential to be present in the organic acid because it has been derived from some sort of organisms. Let us consider an example here. Suppose we have taken an example of acetic acid. The basic formula for acetic acid is CH3COOH. So you can see here carbon is present in this acid. So we can say that organic acid mainly consists of carbon. Now we are coming to our second category, that is the inorganic one. Our second category is inorganic acid, and it is also known as mineral acids. So these acids do not consist of carbon. So they do not consist of carbon. So if they do not consist of carbon, it means there will be a no source from the organism. It means there will be a source from minerals. But in case of inorganic acid, we have one exception. So what is the exception here? We have one exception. The exception here is carbonic acid. Carbonic acid. Carbonic acid is H2CO3. It means it contains carbon, but it is categorized in the category of inorganic acid. So here carbonic acid is an exception. It is only acid that contain carbon and categorized in the category of inorganic acids. So this is all about our first category of the classification based on the source. Now we are moving to our next category. Our second category is classification on the basis of basicity. Classification on basis of basicity. So before proceeding to the classification, firstly we have to understand the term what actually the basicity means. Basicity basically means when an acid is dissolved in water, how much H3O ions, that is hydronium ions, it is going to produce. So number of hydronium ion produced by acid in any solution is termed as basicity. So what is basicity? Here we are writing about the definition of basicity. So basicity means the number of hydronium ions. Hydronium ions are actually H3O positive produced by one molecule of acid in aqueous solution. So the number of hydronium ion, that is H3O positive, produced by the one molecule of acid in the aqueous solution is termed as a basicity. Now we will understand the basicity with the help of an example. Suppose I am considering the acid HCl. Now we have an example here. If I am saying that HCl is dissolved in water, what it is going to give? It is going to give H3O plus plus Cl negative. This is our first example. If I am taking an example, H2SO4 plus H2O, what will be the product? The product will be 2H3 positive plus Cl negative. So you can see from these two examples, there is one hydronium ion produced in the solution because HCl consists of one hydrogen. We can also see here that H2SO4 consists of 2 hydrogen and it is giving 2 hydronium ion. So I must say the basicity of this will be 1 and the basicity of this will be 2. So if we talk about the basicity will be 1 and here the basicity will be 2. So it is all about the basicity of a solution. So on the basis of basicity, the acids are classified into 3 categories. Now we will discuss about the categories on the second classification. On the basis of basicity, we have the 3 classification of acids over here, that is monobasic, dibasic and tribasic acids. So we have again 3 categories. First one is monobasic, second one is dibasic and the third category will be tribasic acid. So these will be the 3 categories of the acid, that is monobasic one, dibasic one and tribasic one. So the monobasic acid is our first category. So mono means single. It means when one molecule of acid dissolved in some aqueous solution produces only one hydronium ion. So we can say this category is termed as monobasic acid. So monobasic acids are those which produce one hydronium ion. Dibasic are producing 2 hydronium ion. Tribasic will going to produce 3 hydronium ion. So if one hydronium ion is produced, we can say that the acid is the monobasic acid. If 2 hydronium ions are produced, we can say that the acid is a dibasic acid. And if the 3 hydronium ions are produced, we can say that the acid is tribasic one. Now we have also 4th category in the series, that is tetrabasic acids. So our 4th category is tetrabasic acids. So tetrabasic acids are actually those acids which are completely ionized in the aqueous solution. So these are the acids which are completely ionized. So again we have the 4 categories here. monobasic, dibasic, tribasic and tetrabasic. Now we will consider the examples to understand all these 4 categories. So firstly, we have an example for monobasic acids. So our first category is monobasic one. So monobasic acids give one hydronium ion in the 1 mole of the acid is dissolved in the aqueous solution. So we have an example in this sequence. So our first example will be hydrochloric acid, acetic acid. Third example will be hydrobromic acid. So these 3 examples we have considered give only 1 hydronium ion. So we will consider it in the category of monobasic acids. They are going to give only 1 hydronium ion, that is H3O positive. Now we are moving to our next category. Our next category is dibasic acids. So our second category is dibasic acids are those acids which give 2 hydronium ion when 1 molecule of acid is dissolved in the aqueous solution. So we have an example of dibasic acids here. Our first example is sulphuric acid, sulphurous acid, third example will be hydrofluoric acid. I am writing the molecular formula of all these acids here. Sulphuric acid stands for H2SO4. Sulphurous acid will be H2SO3. And this is HF, that is hydrofluoric acid. So all 3 categories of the acid used here will going to produce 2 hydronium ions in the case when dissolved in 1 mole of acid. So they will give 2 hydronium ions. So if they are giving 2 hydronium ions, we can say that these are dibasic acids. Now we are moving to our third category. Our third category will be the tribasic acids. So our third category is tribasic acids. Tribasic acids are those acids which give 3 hydronium ions when 1 molecule of acid is dissolved in the aqueous solution. So we have only one example in this category, and the example here is phosphite acid, that is H3PO4. Now this acid will give 3 hydronium ions when dissolved in 1 molecule of acid. Now we are moving to our last category of the acids, that is the fourth one. The fourth category of the acid is tetrabasic acids. As I have already told you, tetrabasic acids have a tendency to dissolve the acid completely in their aqueous solution. So our fourth category is tetrabasic acids. So they have a tendency to dissolve in the aqueous solution. So again, in tetrabasic acids we have the two categories, that is strong acids and weak acids. So again we have the two categories here. First one is strong acids and second category is weak acids. So again we have two categories, that is strong acids and weak acids. But before proceeding to strong acids and weak acids, you can copy it from here. So our next category is strong acids and weak acids. So as the name indicates, strong acids are those acids which are completely ionized in the aqueous solution, and the weak acids are those acids which are partially dissociate into ions in their aqueous solution. So strong acids are those acids which are completely ionized in their aqueous solution. So if an acid is completely ionized, I can consider it in the category of strong one. We have three examples in this category. Examples are, first example is hydrochloric acid. So in case of hydrochloric acid, what we have seen here, when HCl is dissolved in some sort of aqueous solution, it get dissociate into H positive plus Cl negative. It means this is completely ionizable. So we can say that this acid is a strong acid. Second example is sulfuric acid. Sulfuric acid is those acid which give two ions. So it gives 2H plus and SO4 minus 2. So this is the another example of strong acid. We have third acid which is considered in the category of strong acid is hydrochloric acid, nitric acid. So our third example is nitric acid. So nitric acid is HNO3. When HNO3 dissociates, it gives H positive and NO3 minus 2 ions. So this will be the another example for the strong acid. So we can say that hydrochloric acid, sulfuric acid and nitric acid, all the three category of acids are counted in the category of strong acids. So these are strong one. Now we are moving to our next category of the acids, and the next category is weak acids. So the acids which are partially ionized in the aqueous solution are termed as the weak acids. So these will be counted in the category of weak acids. We have more examples in the category of the weak acid. So I am considering the example that is of weak is acetic acid. So we have an example of the category of the weak acid here. Example is acetic acid. The formula for acetic acid is CH3COOH. Now what we will see here, when we dissolve the acetic acid in the aqueous solution, it dissociates partially, that is H positive, and it will form the acetate ion. This ion is known as acetate ion. So we can say that the acids which are partially dissociate into ions in their aqueous solution are considered in the category of the weak acids. So we have the two category of acids here, that is strong one and weak one, and we have classified in the category of tetrabasic acids. Now we have our last classification, that is classification based on the concentration of the acids. So we are moving to our next category, that is on the classification on the basis of concentration. So the last category is classification on basis of concentration. So on the basis of concentration, we have the two category of the acids again, that is the dilute one and concentrated one. So we have the two acids, that is dilute one and concentrated one. So dilute acids are those acids which have more quantity of the water, and the concentrated acids are those acids which have less quantity of water. It means in case of dilute one, water is more and acid is less. In case of the concentrated one, we have more acid and less water. So in case of the dilute one, more water is present, and in this case less water is present. So in this case, quantity of water is more and quantity of acid is less. So we can say that the acids are diluted one. But if the quantity of acid is more and water is less present, we can say that the acids are concentrated. So the concentrated acids are very harmful for us. If they are getting spell on our skin, it will completely burn the skin. So the precaution is given here. So stay away from the acids that are concentrated because it may cause harm to us. Now we can also say that a weak acid is a weak when it is concentrated, because it will not give hydronium ions in the solution. A strong acid will be the strong one if it is diluted, because it have a ability to produce the hydronium ion in the solution. So we can conclude 2 points from here. That is of note purpose. So our first point is strong acid will remain strong even if it is diluted. And weak acid will remain weak if it is concentrated. So we have concluded the 2 points from here, that is the strong acid will remain strong if it is diluted and the weak acid will remain weak if it is concentrated. So it is all about the category of the classification of the acids that we have discussed in today's lecture, that classification based on source. There are 2 sources, organic and inorganic one. Classification based on the basicity, we have the 4 categories here: monobasic, dibasic, tribasic and tetrabasic. In tetrabasic, we have again 2 categories, that is strong acids and weak acids, and we are on the last category, that is based on the concentration of the acids, that is the dilute acids and concentrated acids. So this is all about the classification of the acids based on the 3 categories. Now we are moving to our next topic, that what are the uses of acids and their formula, because it is very important from your exam point of view. It means your 1 mark question will be formed from this type of the uses. So we have our next topic, and our next topic is uses of acids. So in the uses of the acids, again we have the 2 categories, that is mineral acids and organic acids. So today we are going to discuss about the uses of mineral acids. So here I am writing the name of the acid. So here we are writing the name of acid. Here I am writing about its chemical formula. Next we are writing its type. Then we are moving to our last, that is its uses. Now we have different mineral acids we will discuss today, and in the next session we will going to discuss about the organic acids. So our first acid in this category will be, here we are writing serial number. So our first acid is carbonic acid. Carbonic acid is having a general formula H2CO3, and it is basically a type of mineral acid that I have told you earlier. Now carbonic acid is basically used in cold drinks and landfills. It means where there is a need to bubble out carbon dioxide, we will use carbonic acid. So this is used in cold drinks and landfills. Now this will be our first category of the acid we have discussed, that is carbonic acid. Now the second mineral acid we have is nitric acid. Second one is nitric acid. Nitric acid is having a general formula, that is HNO3. It is again classified in the category of mineral acids. And what are the uses of nitric acid? Nitric acid is basically used to make the fertilizers. It is used in fertilizers, it is used in paints, dyes, in textile industry, and it is also used in the extraction of some sort of metals. So it is basically used in fertilizers, textiles, paper, and the fertilizers it is used to make is calcium nitrate, etc. So its basic use will be in the fertilizers industry. Now we are proceeding to our next acid, that is the mineral acid. Our third acid is sulphuric acid. The sulphuric acid is known as the king of the acids and its general formula is H2SO4. It is again categorized in the category of mineral acids, and its basic use of sulphuric acid will be in the industries because it is used for the extraction of metal, paper, dyeing, textile industries, and many more uses. The first important use, it is used in the car batteries for filling the acids in the battery. So it is used in car batteries, extraction of metals, and textile industry also. So this will be the use of sulphuric acid. Now we have our fourth category of the acid, that is phosphoric acid. Phosphoric acid is having a formula H3PO4. So I am writing it here. Our fourth category of acid is phosphoric acid. Phosphoric acid is having a formula H3PO4. Now this is again categorized in the category of mineral acids. This is again mineral acids, and phosphoric acid is usually meant to be used in unrust paints, that is in the industry, and it is used for making fertilizers. So it's used in unrust paints and fertilizers. So this is the 4 uses of the mineral acids we have discussed today. Now in our next lecture we will discuss the use of some organic acids and the classification of acids in further detail. So this lecture is over for today. Thank you so much and have a nice day.